Welcome back, everyone. Today we are going to talk about altitudes in triangles. We will talk about what they are and how to find them. First, you need to know that the altitude of a triangle is the segment from one of the vertices to the line containing the opposite side. It has to be perpendicular to that line on the opposite side. So the reason why it says the line containing the opposite side is because it does not actually have to go to the segment of the opposite side. As you see in this case, we may need to extend that segment to create a line in order for the altitude to intersect the opposite side. So the altitude, another word for it is height. That's why it will be very important when we get to our chapter about area, because we know that the area of a triangle is equal to 1/2 base times height. So if we need to find the height of a triangle, we are looking for the altitude. You also should know the word orthocenter. This is the point of concurrency for all three altitudes in a triangle. So, for example, if we have the three altitudes shown here, segment AF, segment BG, and segment DC, the point where they meet is called the orthocenter. Let's do an example of finding the orthocenter on a coordinate plane. First, it tells us the vertices. I already graphed them. Make sure you label them when you graph them. Now, a hint to you is to look for a side of the triangle that is either vertical or horizontal. This will be the easiest to find something that's perpendicular. I know that for segment FG, it's a horizontal line. Therefore, a segment that is perpendicular would have to be a vertical line. Now I know that the opposite vertex is H, so I want to create a vertical line that goes through point H. So that will look like this. So here's the altitude from point H. Now we need one more altitude. We can either go from point F or from point G. Let's just go from point F. So what I want to do is create a line that is perpendicular to side HG. In order to figure out what will be perpendicular to HG, I will need to find the slope of HG. Remember, slope is equal to rise over run. So I will count here. I see it goes up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So I know my slope is equal to 2 over 1 if I reduce it. So with a slope of 2 over 1, I can find the slope of the perpendicular line by taking the opposite reciprocal. So I know the slope of the perpendicular would be -1/2. Now starting at point F, I know that I need to go down 1 over 2. Down 1 over 2. Down 1 over 2. And connect these points. Now the altitude is not actually going to go outside of the triangle. It's going to stop here on the triangle. So you can go ahead and make this a dotted line if you want, or erase it, or make it a different color maybe. Now let's see, do we know exactly where these two intersected? It's possible that you might know where they intersected. If you need to solve this algebraically, what we need to do is find the find the equation of this green line. I know the slope is -1/2 and it goes through point F, which is the point -2, 4. I can use point slope form to write an equation of the line. So I know the slope is -1/2, and my point x1, y1 is -2, 4. So using point slope form, it's y minus y1 equals m times the quantity x minus x1. I need to fill in y1, m, and x1 with my values here. So my equation should be y minus 4 equals m times the quantity x minus -2, that would be +2. Another way I could have gone about writing this equation is I see that it has the exact y-intercept of 3, so I could use slope-intercept form, which is y equals mx plus b. B stands for the y-intercept, which I know is at 3. So I could also write this by taking the slope and plugging it in for m, and 3 for my b value. Now, if this is the equation of my green line, then I know the x value must be 1, because for my other altitude from point H, I know the x value is 1 along this entire line. So that for my orthocenter, it has to have an x value of 1. In order to figure out the y value, I can go ahead in my equation and plug in 1 for x, because I know x is 1. So let's see what y would equal. I have y equals -1/2 times 1, that's -1/2, plus 3. -1/2 plus 3, it's kind of like 3 minus 1/2, so that would be 2.5 or 2.5. So I know the y value is 2.5, I know the x value is 1, so my orthocenter is at the point 1, 2.5. It's not always necessary to go through the steps of writing the equation, but I wanted to make sure that you knew what you would need to do if it does not intersect at a perfect point where it's a whole number. That's all I have for you for Goal 4. Have a great day.